What's going on, everybody? Johnny Bannon, the networking guru, and we're going to continue on with our CYSA course by jumping back into domain 1.3. If you're following the channel, you know I kind of fell off a little bit on these videos, but I'm getting back into it. I got a new day job, little crazy hectic schedule, but I'm doing it. I'm going to finish the CYSA course. So no more of this face. Let's get into the material. Okay, so we're going to be going over domain 1.3.1. Given a scenario, use appropriate tools or techniques to determine malicious activity. And in this domain, subdomain, we're going to be going over the different kinds of tools. So let me pause the video real quick and bring up the actual exam objectives to see, to show you exactly what we're going to be going over in domain 1.3. Okay, so we're going to go to our exam objectives here just to show you where we're at right now. So we're still in domain 1, which is security operations, and we're going over domain 1.3 right now. And we're just going to be going over the different tools. So we're going to be going up to this sandboxing section. And then the next videos, we'll go over the rest of these exam objectives. So now let's go ahead and get back to the slides. Okay, so again, I have the objectives written out here as well. And if you ever purchase our courses online, you get access to all these slides as well to be downloaded. Okay, so starting off here, let me actually go back to the front. So use appropriate tools or techniques to determine malicious activity. So we're talking about being a SOC analyst, being a cybersecurity operations analyst, a blue teamer, whatever you want to call it. A lot of the times your role is kind of reactive. And, that's not saying that we should be reactive in cybersecurity. It's just how it is. We're doing a lot of monitoring and we're doing a lot of detection and a lot of remediation and response. We're not red teaming. This is not a red teaming cert. This is more of a blue team. That SOC analyst that sits there and monitors dashboards and uses different cybersecurity tools to help defend the network, react, and monitor. So we're going to go over some of these specific tools here. Starting off with packet capture tools. So a packet, let's define what a packet is. I'm coming from a networking background. Originally, I'm a network engineer by heart, right? So to me, a packet is from point A to point B, that entire layer 1 through 7 data, that payload with all of its encapsulation and its headers on it, that's what I consider a packet. Again, from layers 1 to layer 7. So in those packets, sometimes we have malicious activity, right? We could have malware installed on our endpoints that's reaching out to a malicious server. We could have a botnet or a bot on our network reaching out to a command and control server. We could have data exfiltration happening. We could have, again, just those remote connections that we wouldn't know about unless maybe we have to go deep into the packet. When we talk about end-to-end communication as well, sometimes our tools like our SIEMs, our firewalls, our IDS, our IPS systems, they can't always see deeper than layer 5. And what I mean by that is when I make a web session, if I perform a packet capture and a web session being an HTTPS connection, that's end-to-end encrypted using TLS. So if I try to look in that hypertext transfer protocol to see the actual data and the GET request, I won't be able to with those traditional tools unless I do something like TLS decryption and re-encryption. So that's just something to keep in mind with packet captures. Wireshark, TCP dump, the tools that the CYSA exam wants us to go over, these are not like a enterprise solution as far as like, oh, do a Wireshark capture on your router's outbound interface and that's how we're going to monitor. That's just not realistic. A lot of times these tools are to narrow down, right? We got alerted about something and now we need to dive deeper. So we're going to perform a packet capture on a interface, a NIC, whatever the case may be, to allow us to dive deeper. And sometimes to do that deep dive, if we're looking at end-to-end transmissions of our users to a web server, if we have TLS on there, we need to do TLS decryption as well. Now, again, you're going to be like, whoa, man, just teach us the slide here. Tell us what Wireshark does for the test. And yes, I agree. I will. I'll go over this slide, but that's just something to keep in mind when using this tool because it is a great tool to use. Okay, Wireshark. Wireshark is a graphical network protocol analyzer. It allows users to capture live network traffic and analyze it in detail. So pretty simple how it works. Wireshark captures packets from a network interface, and then you get to look in the packet. Now, I could launch Wireshark here and show you, but really what you see here is also what you see on the application. So Let me pause. And okay, here we're at Wireshark. I'm gonna go ahead and capture my Wi-Fi NIC. And I don't have 802.11 actually enabled on here, so we're not gonna be able to see the 802.11 actual frames. Right now, you'll just see emulated 802.3 frames. That's okay, because this is, I just want to show you, what it looks like in real time. So kind of what I was talking about earlier, this TLS session, right? This is a end-to-end web session. And as you can see, I can't see anything beyond this. I can't see the actual HTTP header. Now, again, we can look at other things here. We got ARP request, ICMP request, and we can also filter up here. There's a lot of good courses online that dive deep into filtering and using Wireshark to the best of its capabilities, right? Let's see. There we go, ICMP. And we can filter old things that are just doing ICMP. And I guess I have no ICMP messages coming across, but that's okay, right? We can look at things just doing TLS. Why is it? Did I mess something up? Did I hit stop? Let's see. Continue without saving. Okay, I don't know what happened to my live captures. I feel like I just touched something that messed it up. Okay, anyways, hey, moving on, moving on. But you can filter out here. I think I need like a protocol equals or something like that. Like protocol equals. There's multiple ways to filter through Wireshark, and now it's gonna bug me, and I might pause the video and come back to show you guys how to actually do it. Okay, so I just had to pause the video. I think I was just like hitting enter too many times. Did something messed up. But here we go. Now I'm filtering just via TCP. Okay. To give you a little real world example of this, in my day job, we were working with a let's say a third party. What I would call it our distant end on accessing a virtual desktop infrastructure, a VDI appliance over HTTPS, HTML5 viewer essentially to access that virtual desktop environment. And this was over the WAN. Okay, and the system admins on the other side, the other engineers were saying it's us. Our firewall is blocking something. And so, what I did to prove that it wasn't our network stopping us, our clients from reaching that VDI server, is I did a Wireshark packet capture. I even went to so far as to decrypt the session and show them that their server was giving us a 400 error that had to do with their VDI system recent upgrade. So I used Wireshark to prove something and collaborate and actually show the other team on the wire. No, it's not the network we're reaching there. Completing our TLS session. We're sending you a GET request and we're getting an HTTP error in response. And it had to do something with actually HSTS enforcement that wasn't allowing us to complete that HTML5, that HTTPS session. So Wireshark is a great tool to use. Okay, let's go ahead and back let's go ahead and go back to the slides now. Okay, so moving on. Another packet capture tool is going to be TCP dump. Guys, TCP dump does the exact same thing as Wireshark. It's just not graphical. It's something you run from the command line. So as you see, I have an example here where I did a TCP dump and I'm doing a packet capture on my ETH0 interfaces in my Kali Linux box. But what I'm doing here is I'm adding this extra commands or switches here that say, hey, create this file. So what you're going to notice with Wireshark and these packet captures is you can actually save these packet captures as a file to then reopen at any other Wireshark application. You just save them as a .pcap. So sometimes we're in these Linux servers, or really this any server environment where like we have RHEL 8 servers, RHEL 9 servers that don't have a GUI, so we can't download Wireshark. So how do we do packet inspection then? We use a command line utility like TCP dump, save that TCP dump to a .pcap file, transfer that .pcap file, and then open it in Wireshark, and then we can begin our analysis. TCP dump does the same thing, it's just on the CLI rather than a GUI application. But we usually use it in conjunction with Wireshark when we want to inspect the packets. Now, we could have TCP dump like just show us on the CLI the packets coming across, like we could, but it gets just so confusing. This is my preferred method. Get that packet capture, and if possible, transfer that packet capture file to a computer that has Wireshark on it. Okay, moving on from packet capture tools, now we're going to go over how we do log analysis and correlation in our environments. So first off, what are logs and how do they help us in cybersecurity? So like I said, like as a SOC analyst, a lot of times you're doing what we call log dives, or you have systems that are diving in the logs for you, and then you're making the correlations, doing the proper monitoring and alerting on them. So every system has some sort of log. Windows has their own like OS event logger. I can't remember what it is top of my head right now. Linux has their logs in the var directory. Cisco systems or like network devices use something called syslog, and then other services use syslog as well. And what logs are just text records, records of events that have timestamps that give you artifacts and historics of what's happening on that device. So obviously in a cybersecurity environment, in our SOC environment, that's really important to us. But in a large enterprise, we're not just going to go individually into each device and pull out the log, put it on our computer, go through that logs. For every single device, that would just be impossible. And if we did do that, we'd have huge cyber teams. So we have tools that can help us aggregate logs, do correlation for us, and analysis for us. And again, I say for us, obviously we configure, we do manual administrator intervention and configuration, but then we have automated remediation tools as well that go along with our log analysis and correlation technologies, services, and applications. So a SIEM, this is like, I would say, for a cybersecurity analyst looking for a job, looking for hard skills, knowing how to use a SIEM is like one of the biggest ones, along with like basic things like Linux, right? As far as like a hard skill for a cybersecurity analyst. So SIEM, Security Information Event Management. This is a platform that collects log data from various sources and enables centralized analysis, correlation, alerting, and reporting. So generally how it works, you see my diagram up here that's been in my previous videos. We're ingesting all these logs, and then we can index off them, create dashboards, and we can start doing user behavior analytics, creating behavioral baselines, and then enabling machine learning or large learning models to help us be reactive and remediate on our environments. So I have a little snippet here of how it works. So log data from devices such as firewalls, servers, and endpoints are aggregated into the SIEM. People say it a lot of different ways. The SIEM parses and normalizes the data to make it consistent. That line there is just saying, hey, make it human readable, make a dashboard for this, make it something that I can look at and view. It applies correlation rules that look for patterns indicative of malicious activity. And when a suspicious pattern is detected, the SIEM generates an alert. That's generally, in its simplest form, how it does this. Okay, and here's the other part I was talking about that can be integrated into our SIEM system. SOAR stands for Security Orchestration, Automation, and Response. SOAR platforms extend the capabilities of SIEMs by automating the response process and orchestrating multiple tools. Essentially, what a SOAR does, without getting too deep into the weeds, technically how we would set this up, is we would build a SOAR playbook. And that playbook is, bang, something happens. To the right of that bang, what are the steps we're going to do to remediate that? It's just, this is sometimes even built into the incident response process, but that's all it is. SOAR is just security, orchestration, automation, and response. It's an automated way to do some sort of remediation to a malicious activity or something happening on our network. So, how it works, again, a simple snippet here. A SOAR system receives an alert from a SIEM based on predefined playbooks that you create or that's AI enabled or ML, AI, LLM created. Like, okay, I'm just going to say AI, right? Too many acronyms. It can automatically enrich the alert with context, escalate to analysts, or initiate containment steps. So, again, how you configure it depends on what it's going to do. It's either going to go contain for you or escalate it to us and send us an alert. So use cases for detecting and responding to malicious activity. If a SOAR receives an alert about an endpoint reaching out to a known malicious domain, it can automatically query threat intelligence feeds, retrieve related incident history, and block outbound traffic to that domain. So it can do detection and prevention for us. Okay, moving on to endpoint security. So kind of packet capture, SIEM, and SOAR is about the overall enterprise, right? Looking at networks and looking at the packets on that network and ingesting logs. Kind of more of like overall approach to security. With endpoint security, we're diving into let's protect the actual endpoints, right? How do we protect the actual laptops that users are on to prevent malware or any malicious activity? So the one tool we're going to talk about is EDR. In the exam objectives, it says EDR, but we know there's stuff like XDR that's pretty much doing the same thing. but it centralizes it a little bit more. But what I like to just call this is endpoint security, the modern way of doing it, right? Yes, we still have antivirus, anti-malware that is still used, but a lot of times big organizations are moving more to an EDR, XDR approach, which kind of is taking over that role of antivirus, anti-malware, and kind of this all-in-one endpoint solution. But when the CYSA exam objectives, they want me to talk about EDR, so that's what I'll do. This acronym EDR. EDR tools monitor and collect activity from endpoints in real time, analyze behavior, and respond to threats proactively. So, how does it work? EDR agents are installed on endpoints to log processes, registry changes, file modifications, network connections, and end user behaviors. Pretty much just that heuristics, right? Taking in everything that's going on in that endpoint, creating what's normal, scanning for anything suspicious or malicious like malware or viruses or any suspicious network connections that maybe deviate from a user baseline or reaching out to well known malicious IPs or domains. All that data gets bundled into that EDR solution and is analyzed using rules and machine learning to detect anomalies. And then when those anomalies are detected, we get alerted or it can actually go in and contain or actually prevent, depending how we configure it. Right? I see here in this like little flow chart, it's either we can automate the remediation or we can get an alert, get some context, and we can manually go in based off that EDR alert and quarantine or contain. Okay, domain name, service, and IP reputation. So again, these are just other tools we're going to go over that can help us spot bad or malicious domain names or IPs. So we have a couple tools here we're going to talk about. So just to give it a little definition, attackers often use domain names and IP addresses that are newly registered, rarely used, or known to be associated with malicious behavior. So we have simple tools that can help us detect that and alert us of that, okay? Whether a domain or IP is untrustworthy or could be attached to something malicious. So we have a tool called WHOIS. This is a protocol used to retrieve information about who owns a domain name or an IP address, and this is all publicly available stuff. When you go buy a domain name, it's sent to the registrar. ICANN, that international. It's gonna bug me. Or IANA too. IANA is gonna register that and say this domain name belongs to this person, and this is the service they use, and this is the DNS, the root, the name server, whatever the case may be. It's all public information. So WHOIS is just grabbing all that public information for you about a domain. So this is a protocol used to retrieve information about who owns a domain name or IP address. This data is maintained by domain registrars and includes the registrant's name, organization, contact info, creation and expiration dates, and the domain registrar itself. So you can see here at trepatech.com, this is just my VeriSign Global. I cut it off, but it was Cloudflare, right? We use Cloudflare for our DNS services, and it showed that in there, right? Because again, this is public information. So why is it useful? By checking the WHOIS information, an analyst can see whether a domain was registered recently, who registered it, and whether the data seems suspicious or anonymized. So we have this command line utility tool that I ran on my MacBook, and I didn't have to install anything. I just ran it. I don't know if that's the case for Linux. If you need to install some sort of net tools to use WHOIS, but then we also have this website that did the same thing for me. Okay, all I did was Google WHOIS tool, and it brought me this website that essentially gave me the same info that the CLI, my terminal, did. Just, it has little emojis there. Nice little flag. Okay. Another tool, Abuse IPDB, Abuse IP Database, right? So the DB stands for. This is a database of IP addresses reported for malicious behavior by global cybersecurity communities. It's kind of like the WHOIS tool is just showing you information where Abuse IP database is like, no, this IP has been registered before by some sort of cybersecurity organization. And through us gathering this OSINT, this threat intelligence, we know this IP has been bad in the past, right? So if an endpoint's communicating with an IP that you deem suspicious, you can plug it in here to Abuse IPDB. And this is just an easy tool that you can use to see like, oh yeah, this has been registered to an APT team in the past, a hacker team, or malicious region like Russia, China. I'm in the US, so that's our malicious regions: Iran, Russia, China. So an example scenario, an analyst sees outbound traffic from a server to this 185.203.119.10 IP address, querying Abuse IPDB so that this IP has multiple recent reports of being used in phishing attacks. So just a quick way we can analyze public IP addresses. Okay, Another tool, another command line tool here that's going to help us look to see if anything's malicious in a file is something called strings. So this is a command line utility used to extract human readable text from binary files. Binary files are things that if I tried to show it on the CLI, a binary file, like I typed in cat, this binary file would give me a bunch of crazy hieroglyphics. Well, strings helps us get things that are human readable out of that binary file. So executables, for example, may contain hard-coded URLs, file paths, or error messages that give insight to the file's purpose that we could also see if it was malicious. So why is it useful? Malicious code often contains indicators like domain names, IP addresses, suspicious function names, or attacker usernames. By extracting strings, analysts can gain early insights without executing the file. So we could run strings on like a .exe. We may get a bunch of hieroglyphics if I did like cat this file.exe on the command line. But we can do strings and say, oh, look, I see that they have these weird URLs in here, these human readable URLs. Okay, another free tool that we're going to talk about is VirusTotal. So VirusTotal is a free online service that scans files and URLs using over 70 antivirus engines. Pretty much just looking at those antivirus engines like signature files and things like that based off historics. And it can aggregate metadata such as file hashes, signatures, and community comments. That's kind of like that signature file. And pretty much when you submit to VirusTotal, it allows analysts, say there's not some guy back there actually analyzing it, but it runs it through all these antivirus engines, and these engines can say, hey, that file you just uploaded, there's that file matches this hash that's known for a malicious attack in the past. It's kind of like antivirus, just a tool that's online though, where you don't have to pay all those fees for an actual antivirus tool. You just upload it to virustotal.com, right? So, a good example, we could take an email attachment, download it, and then before we actually open it, I mean, really you shouldn't be downloading it anyways, but let's say you downloaded it and you're like, "Oh man, I don't know if I should have done that." We get security. You're the cybersecurity guy or girl. You say, okay, you downloaded invoice.pdf.exe. I already know that's malicious just because, they're trying to trick you. It's actually an executable. Let me just upload this to VirusTotal, and that scan can reveal that, oh yeah, this file matches a lot of malicious activity. When I did this, making this slide, I literally just went to virustotal.com. I uploaded a PNG file, and this is what it came back with. It's just a bunch of undetected. So again, it was a free one-time use. I'm not sure if it's free always, but it was easy. It took me like 30 seconds to upload this PNG and get these results back. Okay, sandboxing. So sometimes static analysis like strings or VirusTotal isn't enough. Sometimes we may need to see something in a runtime environment to see if it actually is a malicious executable, malicious file, or an actual virus. So obviously if we need to run it in a runtime environment, this file that we suspect is malicious, even though those static analysis maybe didn't give us anything, but we still suspect. So we say, okay, let me put this in a virtualized, isolated environment. Let me run it to see what it actually does. We call that sandboxing, okay? And we're going to go over two sandboxing tools that the CYSA exam wants us to know about. Honestly, you could just deploy VM and do this as well, but we're going to go over specific sandboxing tools. So the first tool we're going to talk about is Joe Sandbox. This is a commercial malware analysis platform that executes files in a virtual environment and records everything the file does. That includes file system changes, registry writes, network communication, and more. So it gives us the ability to run that file, whatever it may be, in a runtime environment, and then it'll let us know if it is malicious or not. It'll give us, information about it. And then we have another one called Cuckoo. I don't really know how to say that. Cuckoo Sandbox. This is an open source sandboxing solution for automated malware analysis. It does like the same thing. It's just an open source solution, right? So this is ideal for teams needing full control over their malware analysis infrastructure. It provides detailed forensic analysis, including screenshots, API calls, memory dumps, and network behavior. Kind of does the same thing, right? This one is just an open source tool. All right, awesome. Now let's go ahead and do our quiz. We got 6 questions, and then I'll see you in the next video. Okay, let's go ahead and do our quiz. I'm going to go to my lessons here, and this is our learning management system that I'm on right now. And I'm going to go down here to this is our lesson page and take our domain quiz. Let me just zoom in a little bit. Okay, so question 1. A user receives an unexpected file attachment named invoice2025.pdf.exe. As a cybersecurity analyst, you want to determine whether the file has been flagged as malware by any antivirus vendors. Which of the following tools should you use first? I'm going to go with this virus total here, right? That's that free website where we can upload and it'll reference 70 different antivirus engines. Question 2. You are investigating suspicious outbound traffic from a corporate server. The destination IP address appears unfamiliar. Which of the following tools would best help you determine whether this IP address is known from malicious activity? So I'm going to go with C, the abuse IP database. So yeah, it's specifically designed for determining the reputation of IP addresses, purely IP addresses. Question 3. Your organization's SIEM has triggered an alert for multiple failed login attempts, followed by successful login to a server from an unfamiliar foreign IP address. What is the main function of the SIEM in this scenario? We're going to go with C here. Collects and correlates log data from multiple sources. That's what it's doing in this exact scenario. Question 4. You have a suspicious executable that appears benign during static analysis, but you suspect it may exhibit malicious behavior when run. You want to execute it in a safe, controlled environment and observe what it does, including any attempts to modify system files or contact external servers. Which tool is best suited for this task? So again, we want to put it in a runtime environment where A, B, and C are all static analysis. So the only viable option here is going to be D, a sandbox. Question 5. An analyst receives an alert from an EDR solution about a PowerShell script that launched from a user's workstation and attempted to download an executable file from an external domain. Which of the following best describes the capabilities of the EDR tool in this context? So it just received an alert. So I'm going to go with A, detecting anomalous behavior and isolating the endpoint. Question 6. Last one. Hopefully we get 100. You are investigating a security incident involving potential data exfiltration. You suspect that a compromised host is transmitting sensitive information to an unknown external server over HTTP. Which of the following tools would allow you to capture and analyze traffic in real time? So the answer I would like is Wireshark, but that's fine. TCP dump works as well. And look at the accuracy, HTTP. Because if it said HTTPS, TCP dump would not be a viable option. It would be TCP dump with SSL decryption. But anyways, I'm digressing again. But yes, TCP dump is the best answer there. And let's go. We got 100%. I want to thank you all for viewing. Make sure you like, subscribe, share with your friends, and I'll see you in the next video.